Hello, today we're looking at lesson 5.3, which is the triangles mini lesson. Just a few things quickly to review about triangles. First of all, if you have an acute triangle, it contains 3 acute angles. If you have an obtuse triangle, it has 1 obtuse angle and 2 acute. And then if you have a right triangle, it has 1 right angle and also 2 acute. So in summary, all triangles have 2 acute angles. It's the third angle that defines it. If the third angle is acute, it's an acute triangle. If the third angle is obtuse, it's an obtuse triangle. And if the third angle is a right angle, then it is a right triangle. Triangles can also be classified based on their sides. Equilateral triangles contain 3 congruent sides and angles. Isosceles triangles contain at least 2 congruent sides and angles. And scalene triangles contain 3 different measures for their sides and angles. So that background knowledge will come into play and help us down the road. Okay, now let's take a look at what we're going to call the triangle sum theorem. Now the triangle sum theorem is a very well-known theorem in geometry. It is used frequently and referenced frequently, and so it's something you really want to be comfortable with. So basically all it tells us is that no matter what the triangle is, no matter what shape or size, the 3 angles will total 180 degrees. And we can use that fact to find missing information or missing angles in a given triangle. So if I start with this first one in example 1, I can see I actually have 2 unknown variables, but they're the same, so that makes this an isosceles triangle. But our equation would just be the 3 angles totaled up that we know, so 114 plus P plus P. So then they total 180 degrees. So now I can combine my like terms, which would be these 2 P's. So it'd be 114 plus 2P is equal to 180. From there, I can subtract the 114 from both sides and find that 2P is equal to 66. Lastly, I would divide by 2 and find that P is equal to 33. Now you could call that degrees, and really you should, because in this particular example, neither angle is labeled with a degree. So that makes both of these angles 33 degrees. In the next one, I can see I'm missing this angle here, which we could either call X, or because it is labeled T, maybe we'll call it angle T. But we'll write the equation just the same. So it would just be 27 plus 82 plus T equals 180. So then I would add together these two, which is 109 plus T will equal 180. And now I can just subtract 109 from both sides, and I'll find that T is equal to 71 degrees. Now the last one over here, I see that I have this little box. That box indicates that this is a right angle, so it's 90 degrees. So my equation would just be 90 plus 52 plus y is equal to 180. From there, I can combine my like terms, so 90 plus 52 would make 142. Then to solve for y, I would subtract 142 from both sides, and I would find that y is equal to 38 degrees. Okay, now they will get a tiny bit harder. Same exact theorem that we're using, but we're going to take a look in example 2 at when we have more algebra to do to complete it, to find the missing angles. So for this one, I still see my 3 angles. They're all in terms of x, so I'm going to add them up and have them total 180. So it would be x plus 6x plus 10 plus x plus 2 equals 180. And I look for my like terms, so I notice I have an x here, plus a 6x here, plus an x here, and then I have a plus 10 and a plus 2. So my 3 x's will add up to give me 8x, 10 and 2 will add up to give me 12, and then together that's equal to 180. Now it's just a standard 2-step equation. And so from here I would start by subtracting my 12 from both sides. And I would find that 8x is equal to 168. Divide by 8. And I would find that x is equal to 21. So now I can go back and find each angle. So this one is obviously 21 degrees. For this one I would plug 21 in for x, and I would get 23 degrees. And then for this one, I would do 6 times 21 plus 10, which is going to give me 126 plus 10, which is 136 degrees. For letter B over here, same idea. I can see I have a 90-degree angle, and then I have 3x plus 4x minus 1. I can group my x's together, so that's 7x. I can group my negative 1 plus 90 together, so that's going to be plus 89. And then that would equal 180. Now I subtract 89 from both sides, and I find that 7x is equal to 91. Now I divide by 7, and I find that x equals 13. So again, I would come up here, I would do 3 times 13 to get 39 degrees for that missing angle. And then here I would do 4 times 13 minus 1, and 4 times 13 would be 52. Minus 1 is 51 degrees. So those are our 2 missing angles. Okay, in the next one, it says the second angle in a triangle is 4 times as large as the first. The first angle and third angle are equal in measure. Find the angle measures. So I'm going to draw a little fake triangle. You don't have to do this. We don't know anything about it other than these descriptions. So it says the second angle is 4 times as large as the first. If I don't know the first, I'm going to call it x. I'm then going to say, okay, the second angle must be 4 times that. And then later it tells me the first and the third are equal. So then that means the third would match the first, which was also x. So then this is actually pretty easy to solve. Our equation would just be x plus 4x equals 180. And when I total those, I would get 6x equals 180. Divide by 6. And I find that x is 30. Now I can go back, and I know that these 2 missing angles, the first and the third, were both 30. And the second angle is 4 times 30, which is 120 degrees. So those are my 3 missing angles. In example 5, it says, what is the measure of angle A? Well, I notice here that I have 71, but the key here is knowing that this is an isosceles triangle. Because these 2 sides are the same, that tells me that the angles are also the same, and so this measure down here would also be 71 degrees. So now if I have to find angle A, I would just have to do 71 plus A is equal to 180. And from there, I can add up what I know, so that's going to be 142 plus A equals 180, and I subtract 142 from both sides to find that A is just 38 degrees. Okay, the next thing we're going to look at is called the exterior angle theorem. And it's kind of a counterintuitive theorem, it's an intuitive theorem, but it says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles, meaning the two that are not next to it. So if we look at angle D here, this would be considered an exterior angle. It is then congruent to the total of C and A. And that's because D is supplementary to B. They would make 180 because they make a straight line. And the total of C and A are also supplementary to B because of the triangle sum theorem. They would total 180. So that gives us this relationship here, which basically just says the measure of angle D would be equal to the sum of the measure of angle A and the measure of angle C. And so we can use that to solve some problems. So let's try that here in this next set. So we have 4 problems we're going to try. The first one says, what are the measures of angle X and angle D? Well, this one you're going to kind of have to use some different information. So I would start by using the triangle sum theorem, which we just did, and find X. So our equation would just be 51 plus 42 plus X equals 180. So 51 and 42 would make 93. 93 plus X would then equal 180. So I would subtract 93 from both sides and find that angle X has a measure of 87. Now that I know that, I can use my exterior angle theorem to solve for D. So using that, I would just say, okay, angle D must equal the sum of the two non-adjacent angles, which would be, sorry, let me rewrite that. So angle D would equal 51 plus 87, which means angle D has a measure of 138 degrees. Next, what is the measure of angle X? Well, angle X I can see is an exterior angle, and I know the two non-adjacent angles, so all I would have to do for this one is total up 75 and 36, and I would get 111 degrees. For the next one, I can see that 100 is an exterior angle, so it would be equal to 40 plus X. So if I'm looking for angle X, all I would need to do is set 100 equal to 40 plus X, subtract 40, and you would find that angle X is 60 degrees. In the next one, I have to use some algebra here, but if I know that 100 must equal the total of these two, then I can set that up as an equation. So I would do 100 is equal to 2x plus 3x, and so that means 100 is equal to 5x. Now I divide by 5, and I find that x is 20. So I can go back and find each angle. 2 times 20 would make this one 40 degrees. 3 times 20 would make this one 60 degrees. The last theorem we're going to look at is the triangle inequality theorem, and it just simply tells us that the sum of any two sides of a triangle must be greater than the measure of the third side. So if I take any two sides, typically the two shorter, and I add them up, and that sum is greater than the third side, then this could be a triangle. So let's look at example 6. So we'll start with A. A cannot be a triangle because if I take the shorter two sides and add them, they actually equal 10. So that won't work, so it's not A. If I take B, 2 plus 3, the two shorter sides, that would be less than the third side, so that's not going to work. But if I take the two shorter sides in C, 3 plus 4, that is greater than the third side, 6, and so C would be a possible triangle. Then we can also do the same thing for D. 2 plus 3 are the two shorter sides. Their angle, or their sides measures they are bigger than the third, the third side is 4. So let's rewrite that. So because the third side is 4, that would work, and D would also be a possible answer here. Okay, now in example 7, it asks us, given the two side lengths, what is the range of lengths of the third side? So what is the minimum and maximum possibilities? So what we would first need to do here is subtract the 2 that we have. So 6 minus 4 gives us 2. So that means that whatever our minimum is, it has to be bigger than 2. So we're just going to increase it by 1. So the minimum measure would be 3. And then to find the maximum, I'm going to add these two sides, and I get 10. So I know that my third side would have to be smaller than that. So I would say that my maximum is 1 smaller than that, assuming that these have to be whole numbers, which would give me a minimum of 3 and a maximum of 9. Then for the last one here, same idea. I would find my minimum by doing 5 minus 3, and that's 2. So if the difference of these two is 2, my minimum would have to be 1 more than that, so that's 3. And then my maximum has to be more than this, or I'm sorry, 1 less than the sum of these two. So 3 plus 5 is 8, and therefore a maximum would be 7. So when you think about these logically, that's just giving you a range of values. So if I had the two shortest sides were 3 and 3, that would still exceed the third. And if my maximum is 7, that's because I could take the 3 and the 5 as the two shorter sides, and they would exceed the third.